All right, so you're gonna need this diagram as well as some colored pencils, markers, or crayons, chalk, I don't care, whatever you want to use, and then separate sheets of paper. What we're gonna do is put a number directly on the diagram itself. And then we're gonna take the separate sheet of paper and we'll write the text part on that and we'll create our own legend. And there's a lot of text here, so you don't want to put it directly on the diagram because it will just be too much. It's very confusing. So just trust me on this one. And if you don't like it, you can reprint your diagrams and then you can do it over again. So we're going to start off with what we already know, which is the bone, right? And this happens to be the femur. And just a little something about this diagram, right? It drives me absolutely bonkers because there's nothing that actually arises from this particular process on the femur. So there's no muscle there. So this is just artistic rendition, right? So artist interpretation. So anyway, it's a nice schematic. So what we're looking at is just muscle that's been divided into smaller pieces and parts. So when it comes to our first structure number one, this is going to be our tendon. A tendon is just dense, fibrous connective tissue that anchors muscle to bone. And we learned that when we talked about articulations. And so tendon, number one. Number two, this is going to be the muscle belly. The muscle belly is just the contractile portion of the whole muscle. And during contraction, the muscle actually shortens. So when you're welcoming people to the gun show, right, you're just showing off your muscle bellies, right, the contractile portions. Mine would be the BB gun show. Right? Now this muscle belly is surrounded by connective tissue. So think of this as being like a sock, right, being put on your foot. And this connective tissue, number three, is called epimysium. With epimysium, this is just a connective tissue layer below the deep fascia, and it covers the entire muscle belly. Right? So it's covering the entire muscle belly, just like your sock covers your foot. From the epimysium, and I'm going to show it in yellow, right? You see these lines here. And then I'm going to show it down here, see in yellow, all the way down here. From the epimysium, we have other connective tissue layers. And this next layer here in yellow, number 4, this is going to be, I'm sorry, my dog is snoring in the background. Piggy. Sorry. So number 4 is perimysium. These videos are going so great, right? So number 4 is perimysium. Perimysium is connective tissue that separates whole muscle into discrete bundles of muscle fibers. Remember, those discrete bundles of muscle fibers were called fascicles. So when you're eating your chicken, right, and you're stripping your chicken away with your teeth and it's just tearing off into certain sections, right, that's going to be the fascicle. Share that with your family during Thanksgiving. I'm sure they'll really appreciate it. All right, just point out, oh, you're just eating fascicles. So the fascicle is going to be our next structure, so number 5. Right, here's number 5. Number 5 is the fascicle. And a fascicle, again, is just a bundle of muscle fibers. It's a bundle of muscle fibers. So now I'm just going to clear away the text on screen, right? But just continue to label on the same diagram. So number 6 is another cell, actually. And this is called a motor neuron. So here in yellow along the fascicle, right, we have number 6, and that's the motor neuron. The motor neuron is a nervous system cell, and this nervous system cell transmits motor commands to the muscle. In other words, the nervous system is in control here. In order for muscle to contract, it actually needs a signal from the nervous system to do so. That makes the skeletal muscle voluntary. So you right now taking notes, when you're actually writing and you're coloring, right, you're voluntarily doing so, whether you feel like it or not. And number 7 is in red here, right? Because these are cells we're talking about, right? Living structures, we have to give them a blood supply. So number 7, that's our blood vessels. And our blood vessels supply oxygen and nutrients to the muscle. Number 8 is another connective tissue structure down here in blue. All right, so here's number 8. And this connective tissue layer is called endomysium. Endo means within. Myo just indicates muscle. So literally within each fascicle, we have connective tissue layers that are surrounding the individual muscle fibers. So endomysium is connective tissue surrounding each individual muscle fiber, right? Because a fascicle is just a bundle of muscle fibers. Again, I'm just going to clear the screen. You guys keep numbering. So I just moved it so you can see the image just a little bit better. Right, so number 9, this is going to be our muscle fiber. And remember, muscle fibers are just super, super, super long cells. So we call them muscle fibers instead of muscle cells. And so cells are made of cell membranes, nucleus, and cytoplasm. So 9A, down here, I've highlighted 9A, this is going to be our cell membrane. But we can't call it a cell membrane because we're talking specifically about muscle. So the term for the cell membrane is now called the sarcolemma. And the sarcolemma is the cell membrane, but it has a fancy new name. Sarco just indicates soft tissue, right? Lemma indicates kind of surrounding or a network. So it's a cell membrane, right? Sarcolemma is the cell membrane. It's rebranded. Then we have 9B, and I'm not going to label it on this particular diagram, but just I want it on your key. So 9B is the nucleus. And there's multiple nuclei per muscle fiber, right? Because remember, these are such long, long, long cells. We don't want one control center. We want multiple control centers, right? So now we have lots of control centers in just one muscle fiber, multiple nuclei. And again, not shown on this diagram. And then add 9C, again, not shown on this diagram, but we have cytoplasm. And instead of calling it cytoplasm, we rebrand it as sarcoplasm, right? Sarcoplasm. Sarcoplasm is cytoplasm, but because it's muscle fiber, again, new name, sarcoplasm. All right, again, I just want that added to your key or to your legend and not on this particular diagram. Then we have just something I just want you to label as SR. SR is called the sarcoplasmic reticulum. With the sarcoplasmic reticulum, number 1, it's in the sarcoplasm, and a reticulum is just a network. So this is a specialized endoplasmic reticulum that stores and releases calcium. Right? Stores and releases calcium. So again, it's just an organelle, right? A specialized endoplasmic reticulum that stores and releases calcium. Then we have our next structures, right? These are specialized intracellular structures, i.e. organelles. And these are going to be number 10, which is the myofibrils. Myofibrils, myo, muscle, fibrils means little fiber. They're just intracellular substructures. I don't know if you guys can hear my dog drinking in the background, but sorry about that. Right, so these are intracellular substructures, or the organelles. So all these long bundles, they span the length of the muscle fiber, right? Myofibrils. So there's thread-like structures in the sarcoplasm that span the length of a muscle fiber. Okay. Sorry. And the myofibrils are surrounded by the sarcoplasmic reticulum. And remember that sarcoplasmic reticulum stored and released calcium. Now, myofibrils are made up of myofilaments. So number 11 down here, these are the myofilaments. So these are just substructures of the myofibril. In other words, they're making up the myofibrils. And with myofilaments, if you recall from our hierarchy of organization, we have thick filaments and we have thin filaments, right? Notice that they both end in the name filament. So myofilaments are comprised of thick filaments and thin filaments. Based off the diagram, I'm sure you can tell which one is which, but I'm not telling you, right? But this one tends to be thicker, this one's thinner. Oh my, there's a tempting little treat. Right, so now it's time to move on to the next diagram.